Hi. Okay, so college algebra, section 1.2. Today we're going to start talking about solving quadratic equations. Again, I expect that you've probably seen at least three-quarters of this material before, but it is really important that you are very aware of some things about quadratic equations. So let's get started, particularly factoring. All right, so quadratic equations have a variable to the second power. Keep in mind, this is like a rule of thumb. The highest power of x in your equation, the highest power of whatever variable you have in your equation, is going to indicate how many solutions you're going to have at the end. So when we looked at linear equations last time, that was x to a single power, and we only we're provided with one answer. So here we have an x squared, so there's always two answers. Now there's a caveat to that, and that is that sometimes the answer is the same answer twice, right? So sometimes x is equal to 2 and x is equal to 2. Okay, that would be a situation where it is still two answers, but it appears to be only one. And we'll talk about that more as it comes up. The answers, when we're talking about solving quadratic equations, are called, of course, the solutions and the roots, but sometimes they're even called the zeros. And that just kind of depends on the context. And you'll talk about that more, I know for sure, in pre-calculus, because that's where we kind of start off in pre-calculus. Okay, so remember, quadratic equation, two answers. All right. Okay, here we go. Now, there's four basic methods for solving quadratics. There's lots of different methods that people use, but these are the four basic ones. The first off, there's factoring, and factoring is one of the most important skills that you can hone in this class, because it allows you to simplify equations and do all sorts of things further along. But factoring only happens when the conditions are right, which really means that it's just a really small subsection of all of the quadratic equations that can actually be solved through factoring. There's also the square root method, and I'm sure that you've used this. This is what you can do when there's no like single term where everything in all the variables in the equation are of a power of 2 or 4 or something to that effect. There's also completing the square, which is a technique that you'll use in the future, more like at the end of your Cal 1 and definitely in your Calculus 2 class. So it's good to go ahead and start understanding it. And it's a process to do, but low key, it is for real my favorite method. And then there's the quadratic formula, which you all should be very familiar with. And that's that tried and true, works every single time, but a lot of times people don't really know what to do with the answers in terms of turning them back into factors. So anyway, these are the basic four methods that we're going to talk about today. Now, again, as many methods as there are to solve a quadratic equation, there are that many different ways people do actual factoring. Okay, I personally know 6 solid ways to factor. I am going to focus on one way. This is the way that I always teach people how to factor because it's very methodical. Okay, so this is called the AC method of factoring. First off, ax squared plus bx plus c equals 0. That is the standard form. That is that standard form. Oops, sorry about that. Of the quadratic, okay? And notice that we have pluses here, but those values in there, of course, can be negatives, right? Because plus and minus is just a minus. So we're all good here. First things first, you need to clear off all the fractions and get rid of the parentheses. Okay, you can't really solve anything unless you're dealing with the square root property of the square root method. You can't solve anything that's already squared. So, or that's in parentheses, unless it's a big parenthesis raised to a power, and we'll talk about that. But general rule of thumb, clear out the fractions. Nobody wants to be thinking about this doing fractions, and get rid of the parentheses. Then we also want to set the equation equal to 0 in descending order, and descending order means from the highest power of the variable down to the constant. Okay. Now, the first step is, after it's all set and ready to go, is you multiply the coefficient of the squared term, that would be the A, and the constant, that would be the C. And that gets you a number. And then you make a list of all the pairs that have that product. Okay, and I am real careful with my list, and I try to show all of the sign options and stuff like that. You don't have to factor like this at all. Of course, if you already know how to factor and you're efficient with it, then no problem. But this is a good method. And then we take from that list and we choose the pair that equal that B value, that value for that middle variable, and then we rewrite the equation, turn it into 4 pieces, and then factor it by grouping. So let's go ahead and take a look at our first example here. Okay, so we have 2x squared equals x plus 3. All right, so the first thing first, we don't have any parentheses, we don't have any fractions, but we do need to set this equation in descending order, set equal to 0. So we're going to say 2x squared minus x minus 3 equals 0, and this is in that form that we need. And now we're going to multiply our 2 times our negative 3. Do mind what that sign is. It'll help you along the way at the end as far as not having to guess what the signs are once you figure out what the numbers are. So we have 2 times negative 3 is equal to negative 6. And the ways that we can get negative 6 is 1 times negative 6 and negative 1 times 6, of course. 2 times negative 3 and negative 2 times 3. Now, you don't have to make the list. You don't have to do all of this, but I'm the teacher. I'm going to show this with all the steps because there might be one of you that just is not good at factoring, or you've been out of school for a while or whatever. Okay, so we've multiplied the A times the C, and we made a list of all the pair that multiply to give us that number. Notice that each pair is going to be listed twice because of the sign situation, right? Because it could be the 2 could be positive and the 3 could be negative, or it could be the 2 is negative and the 3 is positive. So you need to throw down all of your options if that's what you choose to do. And now what we do is we choose the pair that add to be this middle number. So we're looking for negative 1 because that is what the coefficient of x is. So negative 1 minus 6, not negative 1. Negative 1 plus 6, not negative 1. 2 minus 3 is negative 1. And so now what we're going to do is we're going to replace this middle term right here with these guys. Don't forget to put in your x's. So underneath here, I'm going to say plus 2x minus 3x, and then I'm going to just drop those other 2 pieces down. Now we haven't changed the equation at all. We've just used a little bit of algebra trickery, and we've rewritten it into a different form, and that's really where all algebra's strength comes in, is how flexible it is, okay? And so now we just need to factor this guy by grouping. Now I'm going to assume you've seen factor by grouping before, but let's do it. So when you have 4 pieces, in an equation, you can split it in half and you look at the left side and you factor the greatest common factor out of the left side. So we can factor out 2x, and what we're left with is x plus 1. Now, I like to call this guy my twin. And I write it down again. And now we need to fill this hole. And what we want to put in this hole is the number that makes the right half. Okay, so what do we need to multiply x plus 1 by to get negative 3x minus 3? Well, that's a negative 3. Now, when we pull it out of this form, we write the twin down one time because we're basically factoring that x plus 1 out. And we're left with everything that's on the outside of those twins. 2x minus 3. So now we're factored, right? And then what do we do? When we have factors set equal to 0, we get to set each factor equal to 0 and solve it. And remember that we were going to have 2 answers because that was squared. So we get x plus 1 equals 0. So x is equal to negative 1. That one was easy. And 2x minus 3 is equal to 0. So x is equal to 3/2. All right. Cool. Okay, so the next one here, we again don't have any parentheses. We don't have any fractions. So let's put it in descending order. X squared minus 7x equals 0. Now, when you look at this one, this is not, this is a quadratic equation, but it's not a trinomial, right? It doesn't have a constant. So when we are dealt with a situation where there is no constant, you're just going to pull out the greatest common factor here. So that is going to be x times x minus 7 equals 0. These guys are fully factored, just like these two are fully factored. And so now we get to set each of those factors equal to 0. So we have x is equal to 0 and x minus 7 is equal to 0. So x is equal to 7. Okay. Awesome. Let's make it a little bit harder. Oh, I most certainly did make it a little bit harder. I'm going to have to get my calculator out for this. I did not pre-prep any of these questions. I just wrote some down on this PowerPoint. So that's okay. I noticed that your homework is not shy about using large numbers either. So here we go. Okay, so first things first, let's put this guy, no fractions, no parentheses. So let's put this guy in descending order. Now, the first thing I did when I saw this was go, can I factor a number out and make these numbers smaller? And unfortunately, I can't. So we need 12 times 15. That's 180. Now, we can start listing out 180, 1 times 180, 2 times 60, and so forth, right? Or we can go for the easy right away. 180 is 18 times 10. And the difference between 18 and 10 is 8. So seems as though what we're going to need, and this is a negative 180. So we're going to need positive 18 and negative 10. That's going to give us our situation. So let's rewrite this as 18x minus 10x. And please don't forget to stick your x's in there. That's usually the number one mistake I see students do. And then they kind of get lost in the problem, right? Because then it, you don't know, there's nothing common maybe to pull out. Okay. Split it in half. What is the greatest factor in 12 and 18? It looks like 6, so we can pull a, oops, sorry, hold on here. Get a 6x out. We pull out 6x, we're left with 2x plus 3. That's our twin. I'm going to write it down again. And then what do we need to multiply 2x by to get negative 10x? And that would be negative 5. And then we're going to make sure negative 5 times 2x, negative 10x, negative 5 times 3, negative 15. Perfect. So our factors are 6x minus 5, 2x plus 3 equals 0. And now we have 6x minus 5 equals 0. 2x plus 3 equals 0. X is equal to 5, 6. X is equal to negative 3/2. I believe your homework has you put it maybe like this in some brackets, but it has a spot for you to put everything in. Let me make note just in case you forgot this or never knew this or whatever. I want to make sure that you know that negative 1 over 2 and negative 1 over 2 and 1 over negative 2, those are all the same, right? Just want to remind you, sometimes people, and I'm looking at myself, I got stuck on that when I was in college. I didn't have any algebra in high school. I was an embassy kid and I didn't have any like algebra in high school. And when I went to college as an adult, that blew me away. I thought there were 3 different things. Anyway, okay. So let's look at the next one. Aha! We have some fractions. Okay. Now we did this in the last class where we got rid of the fractions right away by multiplying through by the LCD, and we're going to do the same thing here. So the LCD, and the easiest way to do that is write the first denominator down completely. Look at the next denominator, already got it. Last one doesn't have a denominator, LCD is 2. Okay, now we're going to multiply everything through by 2, and I'm going to multiply each piece by 2. That way I don't mess up anywhere. Remember, what you do to one piece in an algebraic equation, you have to do to all the pieces. Every term gets the same. Okay, so these 2's cancel out here, and they cancel out there. That's not a square, that's times 2. Should have wrote it on the other side, but I didn't. So here we have 9x squared plus 1 is equal to 6x. Now we're going to put it in descending order. 9x squared minus 6x plus 1 equals 0. Here we have 9 times 1. So 1 times 9 is positive 9. And how can we get positive 9? Well, we can get a 1 times 9. Negative 1 times negative 9. 3 times 3. And negative 3 times negative 3. And of course, that last one adds to give us our negative 6. So we have negative 3x minus 3x to replace that original negative 6x, and we bring down the other 2 pieces. Does it matter what order you write in? Now, of course, it doesn't here because they're exactly the same, but it doesn't matter what order you write these pieces in at all. Now, you can look ahead and see one way might be easier than the other. You might see one way might force a fraction or some math you don't necessarily want to do, but either way, yeah, it doesn't matter. So here our greatest common factor is 3x, and our twin is going to be 3x minus 1. Get to write that guy down again, 3x minus 1. And now what do we need to multiply 3x minus 1 by to get negative 3x plus 1? It's like negative 1. So our factors here are 3x minus 1 and 3x minus 1. All right, so that is a situation where even though it's a square and there are two answers, the two answers actually turn out to be the same. So you just really want to keep in mind about that. Okay. All right. Let's move to the square root method of factoring. Now, before I talk about this, this comes with a very large warning. Very large warning. Students generally do not use this method properly. And the reason is that they tend to forget that there are going to be two answers, and they take the square root of both sides and they get that answer, and they do not take the plus or minus of the square root of that side. With that being said, it is way better to factor the difference of squares. So let's talk for a second about the difference of squares before I go any further. This is a special subset, right? And if we have an equation in the form of a square minus b square equals 0, and we need to factor it, it factors as a minus b times a plus b. And so that's how it factors out, okay? No matter what these things are, if you can write them in a way that they're squared, then you can always factor them out like this. And let's just do a quick example. X squared minus 144. Okay, now you might already know quite readily what this answer is, right? But if we wanted to factor this, this is x being squared minus 12 being squared. And if we follow what we have here, we get x minus 12, x plus 12. And we get x is equal to 12 and negative 12. Now, I'm going to challenge you to think, when I wrote that problem down, if you hadn't already thought that the answer was 12, but you didn't think about the answer being negative 12, okay? So be careful when you're using the square root method. Now, we are going to use it. It's a very useful tool. I'm just saying that a lot of times students aren't careful enough with it, and they wind up making mistakes. Okay. All right, so how does the square root method work? Well, the first thing is you fully isolate the squared term. That means get the squared thing by itself on, as I prefer, the left-hand side of the equation. That means totally by itself. The only thing on that side is something that is squared. Okay, so if it's like 3x squared, you got to get rid of that 3. You got to leave only the x squared. And then you take the square root of both sides, preserving the plus or minus on the right-hand side of the equation, because you're going to get the two answers. All right, so let's do a couple of examples here. First example, solving by the square root property. We can do that, no problem. First things first, we need to isolate the x squared. So we have x squared is equal to 196. And then we're going to take the square root of both sides. Don't forget the plus or minus. Square root of 196. So now we get x is equal to plus or minus 14. Super easy. Students love to do it, but they forget about the two answers. So still be very, very careful. Okay, let's look at the next one here. We've got to isolate that x squared first. I'm going to add over the 2. Remember, the last step in isolating stuff is to divide something out, because no sense in making fractions if until the very last minute if you are going to make fractions. So first I'm going to add the 2 over 2x squared equals 18. Divide by 2. X squared is equal to 9. And then we can take the square root of both sides. You're like, uh-oh, she forgot it. No, I just wanted to put it in brighter ink here. And x is equal to plus or minus 3. Okay, now we'll do a little bit harder stuff with the square root method, but we're going to do that when we solve after we have completed the square. So let's move on to our third method here. And this method is completing the square, and this method will be heavily relied on when you hit your calculus sequence, okay? It's a very strong manipulation tool for quadratics. So let's look at the steps here. So the first step is that you isolate things with variables on the left and move the constants to the right. So in other words, you just move constants right, leave everything else on the left. Next, kind of like factoring by grouping, you're going to factor out the leading you're going to factor out the leading coefficient. You just want an x squared there. So if there's any number in front of the x squared, you're going to pull it out. Then you're going to set up kind of like this really weird form that I have written here, which shows where I've pulled out the constant. And I don't want you to think, where in the heck did she get this from, right? If I have ax square plus bx, and I divide, which is the same thing as factoring it out, right? I divide both pieces by a, then I wind up with a times x squared plus bx over a, or ba times x, right? That makes sense. Sorry. Okay, so that's where this weird little crazy thing comes from. And this is just like the form. This is like the template that you always roll with these kinds of problems with. Okay, and then we find a value for these empty slots, and that value is this center number, this b over a, in half. So that's that b over a divided by 2. It's half of the x's term. It's me going like this and just dividing that. That's that number that we're getting right there. And then we write it in this completed form right here. And you can notice that the left-hand side is the only side with a variable, and the right-hand side is all numbers. So it's a constant, and then you'll be able to use the square root method to finish it. So let's get started with the first one here. All right. So it's already in the form. The constant is separate from the variables, okay? And so there is no coefficient in front, and so we're going to just set up the form, and it's going to be x squared plus 5x, and then listen to me because I always say it the same, plus the set of parentheses squared equals -4. And remember, what you do to one side of the equation, you must do the exact same thing to the other side of the equation. So plus a set of parentheses squared. This is the form that we're going to set up. Now, what goes inside the parentheses squared is 1/2 of b. So b over 2. So 1/2 of b. So we're going to put 5 halves here and 5 halves here. Okay. Now remember, this is a recording. You can pause it. You can go back. You can listen to it again. You can try a problem pause the video, try the next problem, and then look and see what I wind up doing. There's lots of ways you can use the fact that you're in an online class to your advantage. Okay. All right. So now the next step, and I wish there was a better thing for me to call it, but for years have called it the magic step. We turn into something squared equals this number. And let's figure out what that number is. -4 plus 25/4, right? Just putting this together, that's equal to -16 plus 25, all that crap over 4. You're welcome to use your calculator here. I think this gives us 9/4. Okay, so we've got 9/4 on this side. And what goes in here is one of each thing that's squared. So we have an x squared, so we get an x. And we have a 5/2, and it's positive, so we get a plus 5/2. So our completed square form is this: x plus 5/2 squared is equal to 9/4. Now notice everything on the left-hand side of the equation is all squared. It's in one parenthesis squared. Even though it's not pretty, it's still just one thing that's squared, right? So at this point, we can employ the square root property. Plus or minus. And what we wind up with is x plus 5/2 is equal to a compound equation, plus or minus 3/2. And so at this point, we've got two equations. Scroll down just a little bit. We have x plus 5/2 is equal to positive 3/2, and x plus 5/2 is equal to negative 3/2. So subtracting 5/2 over here, we give x is equal 5/2. That 3/2 minus 5/2 is negative 2/2, which is -1. And if we subtract this over, we have x is equal to negative 8/2, which is -4. Okay. Awesome. All right. I promise you it's not as terrible as it feels like. Let's do another one. Okay. So here we notice that the constant hasn't been moved. So first let's do that. 2x squared minus 8x is equal to 5. And then we need to pull out just the coefficient. It's not the x2, it's only the coefficient. So I'm going to pull this 2 out. And I'm going to be left with x squared minus 4x, and I'm going to go ahead and put in plus a set of parentheses squared, okay, equals to 5 plus, and we've got to be careful because I didn't just add in a set of parentheses squared on the left side. I actually added in 2 times a set of parentheses squared. So I'm going to have to go 2 times that set of parentheses squared. Okay. And now we're ready to just put in that middle term by dividing this guy by 2. So we'll have a -2 in here. I'm going to write our equation. We bring down this 2. We've got this stuff squared equals, and let me figure this out real quick. -2 squared is 4. 4 times 2 is 8. 8 plus 5 is 13. And then we get 1 from this guy and 1 from this guy, and we've got x minus 2. Cool. Okay, so we wind up with 2 times x minus 2 squared equals 13. And we're asked to solve it. So the first thing we're going to need to do is divide both sides by that 2. So we get x minus 2 squared is equal to 13 halves. And now we can take the square root of both sides. And we get x minus 2 is equal to plus or minus the square root of 13 halves. Then we can add that 2 over. Now, I'm going to assume that they are not going to allow an answer like the square root of 13 halves, okay? They want to have rationalized radicals. So we need to rationalize the denominator. Oh, sorry about that. That's what I get for trying to write on the edge. So we got to rationalize the denominator here. So what we have is the square root of 13 over 2. And if we wanted to break that down, that is the square root of 13 over the square root of 2. Now we have to get rid of the square root on the bottom, okay? And the way to do that, the way to get rid of a square root is to kind of have that thing squared. So what will get rid of a square root of 2 is another square root of 2. Now what we do to the bottom, we have to do to the top so that we do not change the integrity of the actual value of the numbers here. Okay, so we would multiply top and bottom by the square root of 2, and that is going to give us the square root of 26 over square root of 2 times the square root of 2 is just 2, and this is now rationalized. So wind up now with x is equal to 2 plus or minus the square root of 26 over 2. Okay, and that actually gives us 2 answers, right? We got 2 plus root 26 over 2, and we've got 2 minus root 26 over 2. I think that your homework does allow for this, so you don't have to do them out separately, but I'm not 100% sure. Okay. All right. I have one more of those I want to do, but I've kind of run out of space and perhaps even a little bit of time. Let me go ahead and do it right here because I wanted to do one more. I'm sorry that it was a last thought as I was getting ready to record that I needed to do one like this. So let's do one more like this, complete the square. And I think it was 5x squared plus x minus 1/10. Also, thank you guys for sticking with me here. I do have the silly phrase, and I usually don't write them, but I think for the first couple weeks I'm going to write them. So let me. I can't spell though, so I don't know if you want me to write what it is or not. PHRAS. Here's the silly phrase of today. This spoon feels goodness. Feels untrustworthy. This spoon feels untrustworthy. Okay. All right. So let's get back here to this completing the square because this one, you guys would have been so mad at me if I did not do an example like this and one of these came up on your homework. I know it. Okay. So let's go ahead and move that 1/10 over, right? And here we have to, listen, you have to pull that 5 out. You're like, but Dr. Kelly, it doesn't come out of the X. It sure the heck does, right? Yeah, it does. Okay, so let's pull out this 5. And that's going to leave us with x squared plus 1/5 x plus a set of parentheses squared. Uh-oh, I might have put myself in a corner over here. Equals 1/10. I'm going to write it really small. Plus 5 times a set of parentheses squared. Ooh, I got it. I'm going to have to scooch over next time. Okay, so what goes in the middle? Same thing that goes in the middle when it's a whole number. Half of 1/5, right? Let's come over here and say 1/5 divided by 2 is equal to 1/5 times 1/2, which is 1/10. Okay. All right. So now we're ready to write the next thing down. We got the 5 parentheses squared equals, this is 1/10 plus 5/100. And I'm going to leave it like that so I can do this easier. That's 10/100, right? And then we're going to pick up one of these guys and one of these guys. So I have x plus 1/10. 5x plus 1/10 squared is equal to 15/100. Now look, I'm not going to simplify this yet because I know I got more things here, right? So now we're going to divide by 5. Dividing that by 5, let me just do a little bit of math right here. I'm sorry, this guy's turning into craziness. 15/100 times 1/5. I'm going to go 5 into 15 and make that a 3/100, okay? So x plus 1/10 squared is equal to, excuse me, 3/100. Now I gotta have a drink. Hold on, I'm gonna have to pause for a second. I'm gonna cough and everything. Okay, so I can breathe now. All righty. And then we'll finish this off. In fact, let me just let you finish this off real quick. Go ahead and pause if necessary. I'm gonna have another drink of my water and give you a minute. Okay, let's see if you did it. So we will wind up here with x plus 1/10 is equal to plus or minus the square root of 3/10. When we take that square root of 100 goes to a 10. We don't have to rationalize. Then we'll add that 1 over. So x is equal to negative 1/10 plus or minus the square root of 3/10. Okay, so let's move on to something that you're more familiar with. I know you all have seen the quadratic formula. Here it is. This is the always works method every single time, no matter if it can factor or not, whether you're missing a term in the middle, whether you're missing the constant, no matter what, you can always use this. This is definitely brute force method, but it always works, okay? So to use this, your equation has to be in descending order, set equal to 0. It's all about what order, what placement all of your variables are in on where you put it in the equation. So putting it in descending order keeps you from looking around and having to look more carefully at, oh, is that the number in front of x? Is that the number in front of x squared? Okay. You do not ever use variables here. You're just using the coefficients, the numbers in front of the variables. These are the coefficients, A, B, and this is the constant. These are coefficients. Okay. All right, and then we have this formula. We just plug and we chug, and it's a good thing. And then I do want to tell you a couple of things right now. There's absolutely a chance that there is no solution. Right? I mentioned that, the number of equations that quadratic equations that can be solved through factoring is just a very, very small percentage of all the equations. And the number of equations that can be solved, period, with any method is also yet a small subset of all the equations. Okay, so there is a lot of them that maybe cannot be solved. But there's something called the discriminant, which is this little piece underneath the square root here. This is called the discriminant. And that can tell you by just doing that calculation real quick. It will tell you if there are any two solutions, one solution, or no solutions. Okay. And basically, if the discriminant is a number greater than 0, then there's going to be two answers. If the discriminant is equal to 0, there's still two answers, but it's the same answer twice. You're not going to catch me on that. Even though I wrote one solution, I'm going to correct that in the language so you understand that. And no solution. If that discriminant is a negative number, well, the square root of a negative number is an imaginary number. It's complex, it's not real. So it's no real solution there. Okay. All right, so let's knock a couple of these guys out. I know you've done this before, but for the people that maybe have not or have not seen them in a while, I've got a couple here. Actually, I'm going to leave these as you-dos. Okay, because I feel like this lecture has gone long. I have way too many examples for the quadratic formula. So let's just get to the ugly ones, shall we? Sounds good, doesn't it? Okay. So just like with factoring and everything else, I am going to absolutely stand firm on getting rid of fractions just from the start. And I like to do fractions, but I like to get rid of fractions just from the start here. So here we see that our LCD is 2, and we multiply everything through by 2, this piece by 2, this piece by 2, this piece by 2. Wrote it on the right side this time. Yay, I'm improving today. So those cancel out. We have 25x squared plus 2 times 18 is 36 is equal to 60x. Okay, then we're going to put it in descending order. 25x squared minus 60x plus 36 equals 0. I always look to see if I can simplify my numbers. I always look because this equation is set equal to 0. Anything you factor out of it, number-wise, you can divide out and get rid of. Unfortunately, none of these really make prettiness. So we've got A is 25, B is negative 60, C is 36. Expect ugly numbers. When I assigned the homework options are a lot of ugly numbers. Therefore, I wanted to be sure to do some ugly numbers for you. Okay, so remember the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c in that entire t over 2 times a. That's the other part people mess up on. They don't bring that line all the way across and make sure that everything's divided by 2a. So do be careful with that. All right, here we go. X is equal to negative b plus or minus the square root of b squared. So negative 60 squared minus 4 times 25 times 36 all over 2 times 25. Okay, and then we'll clean that up. So 60 plus or minus the square root of some crap here. Let's see what it is. I'm going to do it on my calculator. So if you plug a negative number into your calculator to then raise it to a power, please put that number in its own set of parentheses. Okay. We got 60 squared minus 4 times 25 times 36. That gives us 0. Ooh, nice. I didn't expect that. 2 times 25 is 50. So that means that our answer is 6/5 and 6/5. Now they're only going to ask you to write it once. Writing it twice is redundant, but I want to make sure that you know this had an x square in it and there were two answers. They just so happen to be the same one. Okay, awesome. Let's look at this next problem. And then we got a couple of application problems to do, and then we'll be done. Listen, if the lecture is too long, y'all just pause, take a break, come back, okay? Please do that, or I'm going to wind up posting like 4 lectures a week. And remember, in the class, your lecture is for an hour and 15 minutes. So I try not to go that long, but it can happen. So take advantage of the fact you're online. Take advantage of the fact that you can pause and take a break and walk away for a few minutes. Absolutely. Okay, so let's do the next one here. And we see we have fractions. So let us get our LCDs. Now, if you stink at LCDs, if something isn't a fraction, put a 1 underneath it. It'll remind you. You'll quit needing to do that, okay? So remember, what's the gig? You look at the first denominator and write down its denominator. Then we look at the next. There's an x. We look at the next. There's an x squared. Well, I already have 1x, but I need 2 x's. So it won't be x cubed. It's going to be just one more x. So the full LCD is x squared. And then we're going to multiply everything by x squared. Perfect. So we get 9x squared plus 3x equals 2. Let's bring that over. 9x squared plus 3x minus 2 equals 0. And we will find our A, which is 9, our B, which is 3, our C, which is -2. Now, one thing to note here, started as a rational, meaning variable in the denominator. So we must check that the solution does not make the denominator 0. Now, there's only one thing that'll make this denominator 0, and that's if the answer is 0, and clearly the answer is not 0. However, anytime you see a variable in the bottom and you clean it up so you can work with it, because you can never solve for a variable in a denominator, by the way, you will always have to manipulate it out of the denominator. Okay, you've got to just check those answers. And I'm going to reinforce that till it sticks in your head so you don't have to think about it. All right, cool. Let's do it here. So we have x is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Now let's see here. We got negative 3 plus or minus, let's see, we've got 9 minus 4 times 9 times negative 2 gives us 81. Oh, how nice is that? Thank you. Negative 3 plus or minus 9 over 18. So we get two answers here. We have negative 3 plus 9 over 18 and negative 3 minus 9 over 18. Negative 12 over 18. You are going to be required to reduce your fractions. So be sure that you got that. Let's see what goes in there is 3, which is negative, 6, which is negative 2/3. Whew. That was tough. My brain's tired. Okay, let's see what's left. Oh, joy. We got 2 application problems. Okay, and there's one very similar to this in your homework. I try to make sure that my application problem examples that I do kind of match the questions that are asked in the homework. Not fully, I'm not doing every single example because you have to struggle, you have to kind of extend and stuff like that. However, if I see a crazy one, I'm going to make sure that I do something similar so you got something to follow. Okay, so here's the idea. This is a square of sheet metal of undetermined size, and I need to construct an open top box that'll hold 144 centimeters in volume. The box has to be 9 centimeters tall, so I cut out 4 9-centimeter squares out of each corner, leaving the 4 sides to be bent upwards. What size should I start the sheet of metal with? So let me make sure you understand what's going on, okay? So I'm going to make this box, and it's going to kind of wind up looking a little bit like a 3D box, kind of like this. I'm going to probably draw it really bad, but this is what we're trying to do here. Trying to get us a little 3D box like this, but it's open. The top is open. And it needs to be 9 centimeters tall. So what we're going to do out of this sheet metal, and so in each side is one of these things that is folded up. So let's see. So I'm going to draw a picture of what I think it's going to look like. And remember, it doesn't have to be to scale, but a picture definitely helps your brain kind of think about it, right? So these are 9 inches. We're going to take all these out. We'll cut them all out. Okay. So this is 9 inches and this is 9 inches. Every side here is 9 inches. The question is, what's this? These are the sides that are 9 inches. Let me erase this because my picture looks way better in my notes. I can't show it to you though. So the question is, if that's 9 inches, this down here is also 9 inches, right? I should write it on the inside. I'm super sorry. Let me just see if I can't make this better. I might just be making it worse. So this is 9 and this is 9. What is this? Right? What is this? If the length of this sheet, we don't know what the length of this is, this would be X length. Then what is this? Well, this part right here is going to be X minus 2 times the 9. So X minus 2 of those 9s, which is the same thing as X minus 18. So that means that the bottom here, right, these are going to be 9 inches tall. And this is going to be the X minus 2 times 9. So if we're talking about volume, volume of a cube is going to be the length times the width times the height. Right? And so if this is the length, this is the width, and this is the height. So our length is going to be X minus 18. Our width is going to also then be X minus 18. And the height is going to be 9 because that's what we know for sure. It has to be 9 tall to hold 144 centimeters in volume. Okay, so let's get our equation together then. So our equation is length times width times height equals volume. So we're going to have X minus 18 times X minus 18 times 9 equals 144. Now we can solve this pretty quickly using the square root property. First things first, I'm going to divide both sides by 9, which my brain is not going to allow to happen. 16. So we get 9. So we now have X minus 18, I think we can all agree is squared, is equal to 16. And now we can use the square root property. We have X minus 18 is equal to plus or minus 4. So we'll have X minus 18 equals 4. And X minus 18 equals negative 4. Adding 18 over, we'll have X is equal to 22. And adding 18 over, we'll have X is equal to 18. So it looks like we can make either from a 22-inch box or 22 centimeter sheet, or from an 18 centimeter sheet. Now, if we had done this math and one of these turned out to be negative, well then that doesn't work at all, right? You can't have negative length. But these both came out positive, so you can make a box with a 9 centimeter tall height that'll hold 144 centimeters in volume by either using a 22 centimeter sheet or an 18 centimeter sheet. Now, if this question was something like, what is the smallest sheet? Then clearly we could say, or what is the largest sheet? We could say. Okay, cool. We have one last question. And it's another application problem. A right triangle has the hypotenuse of 2x plus 5 and legs of 2x minus 3 and x plus 8. Find x and the length of each side. Okay, so let's remember a couple of things about a right triangle. This is a very crappy right triangle, but we know it's a right triangle because I put this little square in the bottom. So it doesn't matter how crappy the triangle is drawn, we know it's a right triangle. This is a hypotenuse, this is a leg, and this is a leg. Okay, now let's go back to our question. The question says the right triangle has a hypotenuse of 2x plus 5 and legs of 2x minus 3 and x plus 8. Okay, so we've got it set up, but now we're like, darn, we've got to remember something, right? And what is it that we have to remember? We have to remember the Pythagorean identity that you've heard for a really long time, which is a squared plus b squared, I don't know, is equal to c squared, where a and b are legs of a right triangle. Remember, this only works for right triangles. And c is the hypotenuse of the right triangle. Cannot apply this rule that gets beat into our heads to anything but right triangles. Okay, fortunately, we can model a lot of things with right triangles. So, yay. Okay, so with that being known, how do we set this up? Absolutely, it's going to be 2x minus 3 squared plus x plus 8 squared is equal to 2x plus 5 squared. And now you get to practice your foiling out here. We've got 4x squared. 2x times negative 3 is negative 6 times 2 is minus 12x plus 9. That gets that first one plus x squared. 2 times 8x is 16x plus 8 squared is 64 equals 2x squared is 4x squared. 2 times 5 is 10 times 2 is plus 20x plus 25. Now I'm going to take the time to clean all this stuff up here. We've got 3x squared plus 4x plus 73 is equal to 4x squared plus 20x plus 25. Oh, look at that. I dropped that x. I saw it when I did it. Okay, move everything to the left. Actually, I'm going to move everything to the right. See, if I move everything to the left, I'm going to have a negative x squared. I'm going to have to move some other stuff. So I'm just going to move everything over here to the right and put the 0 on the left. And so when we do that, we get x squared plus 16x minus 48 is equal to 0. I recognize that this is something I can easily factor. And so I'm doing it. Right? No number in front makes it really easy to factor if it's factorable. So I get x is equal to 4 and x is equal to -12. Now we're talking about the length. We're talking about a measurement. So x is equal to -12 is not reasonable and is not a solution here. And then finally it asks for the sides. So we can say one leg is 2 times 4 minus 3, which is 5. Another leg here, which is 4 plus 8, which is 12. And then the hypotenuse, which is 2 times 4 plus 5, which is 13. All right, we did it. Yay! Okay. You guys have a good day. I want to remind you of a couple of quick things though. So all your homework and all your attendance quizzes are not due until that deadline before the exam. So be sure to be looking at your course agenda so you know what's happening, so no one's panicking and sending me a bunch of stuff this week in a panic. Okay, you're welcome to, but I'm probably not going to go on and grade hardly anything until after the due date. All right, y'all have a good day.